Most supplements are a waste of money. That's my stock answer whenever somebody asks me about them. I recommend that masters engaged in heavy training get as much nutrition as possible the old-fashioned way, from food. This includes both macronutrients, fats, carbs, protein, and micronutrients, vitamins and minerals. Some masters may have trouble getting their full whack of protein, mandating a protein supplement, preferably of whey, preferably rich in branched-chain amino acids. But if you can get the required protein from your meat, fish, eggs, and dairy, that's much better. Micronutrients come from a varied real food diet rich in fatty wild fishes, grass-fed stock, sugar-free dairy, fruits, and vegetables. If your diet is rich and varied enough, you shouldn't need vitamin supplements. My suspicion, based on what little good research there is and a fair amount of physiological reasoning, is that most dietary supplements consumed in an artificial vector just get filtered in the nephron and end up in the urine. $20 a bottle is a lot to pay for fortified, vitamin-rich, supplemented pee. However, there is one supplement that I recommend almost universally: creatine. Creatine is a simple nitrogenous compound, an organic molecule containing nitrogen that can carry a high-energy phosphate. That makes it a very useful and powerful metabolic adjunct. When you're engaged in high-intensity training, like, say, a set of heavy presses or deads, or a sprint, or a prowler push, your energy utilization is tilted heavily toward the so-called anaerobic end of the energy spectrum, which I prefer to call the cytosolic energy system. You can't do oxidative metabolism of sugar or fat fast enough to generate enough ATP to get the job done. In other words, aerobic metabolism just doesn't have the power output to lift a damn heavy bar 5 times. To do that, you have to rely on 2 primary anaerobic energy systems, located not in the oxygen-breathing mitochondria, but in the cytoplasm of the muscle cell. These are the phosphagen, or immediate energy system, and the glycolytic system. The glycolytic system comes online later in the set, splitting glucose into lactate or pyruvate for rapid energy in the form of ATP. But before that, when the set first starts, you're using the ATP that's already in your muscles. The problem is, for a heavy effort, that ATP stash will last mere seconds before it peters out. The ATP all splits into ADP, giving up its energy. You have to recharge that ADP to keep working. You could pump that spent ADP through the mitochondria to make ATP with oxidative metabolism, the actual combustion of sugar and fat with oxygen. But again, that takes way too long, which is why huffing and puffing in the middle of a set to catch your breath doesn't do you a lot of good. Or you could split sugar with glycolysis to recharge that ADP to ATP. That's faster and much more powerful, but it takes a few seconds to come online, and the power output may not be quite adequate to get the job done, although glycolysis is a high-power energy system, to be sure. There is another alternative. If you had a depot of high-energy phosphate sitting in the muscle, ready to transfer that phosphate to another molecule, you could recharge the ADP into ATP instantly, on the spot, for continuation of very high-intensity work. And you do have such a depot: creatine. Creatine is present in the diet, particularly in meat, and is found in high concentrations in our muscles, brains, kidneys, and testicles, suggesting a range of more or less palatable dietary choices, depending on your affinity for offal. These tissues all have high bioenergetic power outputs that cannot be allowed to flag. Creatine can be charged with high-energy phosphate to form creatine phosphate, or phosphocreatine, which is ready to recharge ADP under conditions of high energy utilization to keep biochemical and mechanical power output high. If we have adequate creatine in the diet, and especially if we supplement creatine, we will increase the concentration of creatine in our tissues, including muscle. And if we train our muscles, then during rest and recovery, our aerobic system will use some of the energy from oxidation of fat and carbs to charge that creatine and load up our muscles with phosphocreatine. So here you are, packed with phosphocreatine, working under the bar. By the second rep, you're already working damn hard, and the ATP in your muscles is just about used up. Glycolysis is just barely coming online. You're going to run out of juice. Except you're ready. Phosphocreatine rapidly recharges the ADP residues on the spot, providing a few more precious seconds of high-power work to get you through the set, with a little help from glycolysis. Phosphocreatine doesn't make you stronger. It gives you a few extra seconds of anaerobic energy, so you can squeeze out that extra rep, so you can get stronger. Creatine is relatively cheap, safe, and bioavailable. Although there are many fancy formulations, plain old creatine monohydrate will do just fine. You don't need a fancy loading protocol or special dosing regimens. Just take a creatine supplement daily, whether it's a training day or not. If you have heart, liver, or kidney disease, don't take creatine without a nod from your doctor. You might have seen some media stories suggesting that creatine is neuroprotective or good for this or that disease. The last time I looked at this literature, no demonstration of anything of the sort was in evidence. But the exercise science data, which I remind you is not generally of the highest quality, strongly suggests that, on balance, creatine gives us a slight edge under the bar without significant ill effects, except perhaps to our pocketbooks. If you train heavy, you might consider trying it. It's one of the few supplements I recommend, aside from caffeine, which I hesitate to call a supplement, and prefer to call the elixir of life. But that's another episode. Thanks for watching. Until next time, stay strong and stay healthy.